Hi again. Here we are. The previous multi-level video lecture stopped. We finished by adding 2 individual level variables that could predict performance, right? So I will show you now, and this is, I guess, pretty much the same procedure that we also used in the previous video lecture. But okay, I will do it anyway, is to add team level indicators. So we have actually 2 team level indicators in this data set, or independent variables that could predict the outcome variable. So we have team size and a team key performance indicator. So this is some kind of team performance score. So let's add both to the model. I will grant mean center, always grant mean center the team level variables, the highest level variables. Because actually you cannot group mean center the variables, or that might be actually interesting. So I grant mean the scores here. I will see why. I will show you why I do that. Okay. So of course we can press start again. We get output. So why do I actually always grant mean center the team level scores? Good question. Because they don't have any variance on the lowest level. So they only have variation between teams. They have no variation whatsoever within teams, because each team member is embedded in the same team, and this team has only one indicator for team performance. So let's, just for fun, center the variables on the team mean, okay? Not on the sample mean, the grant mean, but on the team mean. What happens? Let's do the other one also. It's late tonight, so let's have some fun with this. Team. What happens? Start. 0. 0. Of course, because they don't have any variance on the lowest level. And this is also what we talked about a little bit. So when you do like ordinary regression analysis, you would do so totally wrong stuff, because you would add all these scores to the individual level, the team size scores and the team KPI, and you do as if they vary on the lowest level. But of course they do not. So never perform ordinary regression analysis with a multi-level data set. Or that is my advice, at least. So yes. And this also indicates that they can only predict predict some variance on the team level, because they are team level variables, so they cannot predict individual level variance, right? I hope you understand it. And now let's go a little bit on with this centering. So maybe I'm deviating a little bit, but I'm getting excited. So you could also say that, and I showed you this a little bit in this lecture also, you can also say individual level variables, I center them on the team mean. This means actually, this means that you only look at variations on a within team level perspective. So you would actually not predict anything on the between team level. Right, so here we have work, pressure, only the within team, the lowest level variance. And then you see here it works, because work pressure also varies between employees within each of the teams. Okay? So that's the biggest difference. But now we see that on a within team level, actually it predicts on the variance. I hope this is a little bit clear. So let's put the team variables. Hey, oh yeah, I made a mess of things now, of course, by doing that. Here we go. So if I click modify, and oh, okay, these are the other way around now, but no. Let's look at the output. So now we can go into the similar kind of analysis we did before. So we are building actually nested models. So here we can enter the estimate. It's now 3.960. Oh, comma. How many times am I going to do this? Comma 031. Work pressure is now on the second. So work pressure 179, the estimates, and comma 149, standard error. And now we have autonomy 0, 046, 035. And of course we have two new variables, team size and team KPI. Team size 5. And we can actually look at now the variance explained again. 0.097, comma, and we have 217. So here you see it on the variance that is still unexplained on the team level. It dropped quite a bit, and the level that's unexplained on the individual level. Well, we can look at the individual levels, the z-value, and you see again 3.65. You can use the npro command I showed you before, but you will see that there's a p-value of 0.001. 1,314 will be not significant because we have a z-value that is lower than 1,96. And the same goes for team size. Oh, and I forgot to enter team KPI, key performance indicators on the team level, 6. And here we have another significant z-value. So you see that work pressure and team performance indicators predict individual level performance. And of course, did we enter? Yeah, these are the variances. And the deviance score we can enter again 723.0, 723.087. Yep. So again, we can look at variance explained. So yeah, you can look at the additional variance explained, of course, when comparing these two. But I always look at the total variance explained. So, but you can decide for yourself. So I would say this unexplained variance minus the leftover unexplained variance is the explained variance, right? And we divide that by the total amount of variance. And we do the same for this one. No. And then you see actually a bit of a strange thing going on. First of all, I have to get between the brackets. Yes. Okay. Is that right? Percentage. This is not right. This. Unexplained, yeah. So because we have a strange thing here, and -1, which is pretty strange. So I actually asked MlwiN software developers on how this can be, because you cannot explain negative variance, of course. But yeah, they told me that MlwiN, okay, now we have entered two team level variables that do not in any way predict variance on the individual level. I showed you also that in the MlwiN just 5 minutes ago. So, and then MlwiN has some trouble with taking that into account. They have to correct for it. Some way, I'm not sure. I'm not a software developer. So, okay. But let's say this is 0, and then we have 12% of the total variance is explained on a team level, actually. And let's say no variance is explained on the individual level. So, that's still not a lot, but okay, this is behavioral sciences. And of course, we can also see whether or not this model with 4 indicators fits the data better as compared to maybe the model 1 you want to compare it with, right? So model 1 deviance score minus model 2, and remember the chi-square, the deviance you want to have as low as possible, just as in structural equation modeling in AMOS. So 29.91 basically is the chi-square difference. We go again to command interface. The C Pro is 21.91. And we added 2 extra variables. So 2 extra variables. The degrees of freedom is 2, and we see here again it's 0.000 something. So p-value again, we copy this is. So you see the second model fits the data significantly better as compared to the model 1, and model 1 fits the data significantly better as compared to the null model. So okay, I will stop this video lecture now, and I will continue with the final lecture, and the final lecture will be about randomization of the slope.